All right, number one, match each function with its equation on the next page, then identify which function pairs are reciprocals. Let's just go ahead and, so I took the liberty to rewrite these 6 functions down here, but I factored them as well as I could. Like here, this is a total mess. Like I expanded this and I included the -1, and then I pulled out the leading coefficient. X squared minus 4x plus 5 actually doesn't factor. So this is the best we can do. This is the most factored we can get. For this one, this is a difference of squares. I marked it as x minus 1, x plus 1 on the bottom there. I took out the leading coefficient of 2x minus 5 to get 2x minus 5 halves. So I did this so that we could easily find the zeros and the asymptotes and everything that we need to find so that we can match it with the graph easily. Also, I mean, it's pretty obvious. It says at the end to identify which function pairs are reciprocals. I mean, let's just do that right away. These guys are reciprocals because one is 1 over the other. See these guys, you can see, A is just 1 over E, and then B and D are reciprocals. B is just 1 over D. D is actually just 1 over B as well, if you want to get down to it. So these two, and these two. All right, let's get on with the rest of it. So match each function with its equation on the next, so match these with these functions. That should be pretty easy. All right, let's see. This we have no x intercepts. We have, this can never be 0 either, so there are no asymptotes, no x-intercepts. No matter what I plug in, like if I plug in a really big x value, this should be negative. The degree on top and degree on bottom, it's lower on the top, so it's going to approach 0. So let's see what does that. So it's going to be negative to the right. That's positive. This doesn't approach 0. This is positive to the right. Oh, here we go, negative to the right. Looks like this, and approaching 0. Looks like B is this one right here. Even when you have a negative infinity, this is going to be positive, so minus that, so it's going to be approaching 0 from the negative side as well. And like I said, there are no asymptotes, no zeros. This fits it perfectly. All right, so let's say, color this one in and say that it is this one. All right, let's just go to his partner right away. We'll make the partner orange to see the difference. Now, again, I get no asymptotes and no zeros, right? This is just over 1. But when I plug in infinity here, x squared, this gets really, really, really big now. So negative infinity. So it'll actually go to negative infinity. This one goes to negative infinity. There you go. And what about when I plug in negative infinity, it also goes to negative infinity. So looks like this one's going to be it. And also, if you look at this reciprocal, check this out. Whenever this is at 0, approaching 0, and then it goes down and then back up to 0, this one is approaching infinity, and it goes up and then it goes back down to infinity. It does like the opposite. When this one is equal to -1, this one is also equal to -1. Well, that makes sense. 1 over -1 is also -1. So if one of them equals -1, the other one is just 1 over that. So it'll be -1. When this is close to 0, well, what's 1 over close to 0? Well, that's going to be a huge number. Close to 0, huge number. And when it's a huge number, well, what's 1 over a huge number? Close to 0. Right? So each spot here, it makes sense that these guys are reciprocals. All right, so this orange guy is obviously this right here. All right, let's do part be. So what do we got? We have no zeros, right? Because we have a 1 on top. That can never be 0. We have two asymptotes at 1 and -1. Let's see if there's anything that has two asymptotes. This one doesn't. This one doesn't. This one has two asymptotes, 1 and -1. So this is the one. This one doesn't. All right, so this guy right here is the green one. Let's make its partner blue. So his partner is right here in blue. Now let's look at it. Let's compare it to this. So when you have an asymptote, it's because it's 1 divided by 0. Well, what's 1 over 1 divided by 0? Well, that would be 0 divided by 1. Right? So whenever you have an asymptote, because it's 1 over 0, instead you have a 0, which is 0 over 1. So to find at 1 and -1, we should have zeros. So not that one, not that one. Aha! 1 and -1, we have zeros. So you see how the 0 corresponds to an asymptote? The 0 corresponds to an asymptote. Now this gets down to -1. Well, the reciprocal of -1 is 1 over -1, which is also -1. And sure enough, right here, it's -1. Now this goes closer and closer and closer to 0 on this side. It means this one goes closer and closer and closer to infinity. Over here, it goes closer and closer to 0. This side, closer and closer to infinity. It's the reciprocal. Here you go from 0, closer and closer and closer to infinity. Well, that means it goes from infinity closer and closer and closer to 0. Right where it crosses 1, right here, the reciprocal will be 1 over 1. It'll cross 1 as well. When this is at 2, this will be at 1/2, because 1 over 2. When this is at 1/2, what's 1 over 1/2 is 2. So this one will be at +2. Right? So the height here will be the reciprocal of the height here. So whatever the height is, let's say the height here is 4. Well, then the height on this one, so at -2, the height is 4. If you go to -2, the height is 1 over 4, 1/4. At +2, the height is 4. +2, the height is 1 over 4, 1/4. And so this guy is the reciprocal. These two are reciprocals, the green and the blue. All right, let's go to part C. We will make that one, let's say, black. All right, so obviously we're looking here at, on the bottom we have when x is 5/2, so 2.5, we're going to have an asymptote. Definitely this one, that's where my asymptote is. Oh, and look at that, its reciprocal will have a 0 at that same spot. Whenever something has an asymptote, its reciprocal will have a 0. Well, that makes sense, because an asymptote is when you have 1 divided by 0. And a 0 is when you have 0 divided by 1. So that makes sense. So this gray guy is this. And his reciprocal, let's make it yellow, will be this. And now let's just look at more points here. So you have here, this is getting bigger and bigger and bigger. At x equals 4, you have y is 3. So let's look at x equals 4, and you have y is 1 over 3. At x equals 3 here, y is equal to 1. Well, at x equals 3 here, y is equal to 1 over 1, which is also 1. So it's interesting, wherever it crosses 1, its partner will also cross 1. Wherever it crosses -1, so at 2 you cross -1, at 2 you're at -1. It also crosses -1, because 1 over -1 is the same thing. But wherever it's lower than -1, this will be higher than -1. Wherever it's higher than -1, this will be lower than -1. As it gets closer to 0, this one gets closer to, well, this is negative, so this one also has to be negative, and it gets closer to infinity. On the other side, when it's close to 0, this one's close to infinity. As this gets close to infinity, this one gets close to 0. Notice another thing, whenever this one's positive, this one's also positive, because if you have 1 over a positive, it'd still be positive. Whenever this guy's negative, its partner is also negative, because 1 over negative is also a negative. And that goes for any partners. Okay, so once you have the graph of any function, you can easily find its reciprocal. You just, wherever there's a 1 or a negative 1, you just plot the exact same point because they're the same. Whenever it goes lower than 1, the other one goes higher, and whenever it goes higher, the other one goes lower. And any specific point, let's say I find the point is negative 4.8, well then its partner will just be negative 1 over 4.8. So here, negative 4.8 is just beyond 2, so go just beyond 2, and it's negative 1 over 4.8. So that's going to be like negative point something small. For each pair of functions, determine where the zeros of the original function occur and state the equations of the vertical asymptotes of the reciprocal function, if possible. Well, that'll be easy because whatever the zeros of the original are going to be the vertical asymptotes of the reciprocal. All right, so here the 0 is x is 6, and the reciprocal function is this one, and the vertical asymptote happens at x equals 6. Here you've got the 0 at negative 4/3, and here the asymptote happens at negative 4/3. Here you've got, well, I guess I'm going to have to factor this one. So we've got x minus 5, x plus 3 is this guy factored. And so g of x, the vertical asymptotes will be at x equals 5 and x equals negative 3. Here the zeros are at x equals 5 and x equals negative 3. All right, 4x squared minus 25. That's the difference of squares. So 2x plus 5, 2x minus 5, which means the zeros will be at 5 halves and negative 5 halves. Well, then the vertical asymptotes will be at 5 halves and negative 5 halves. Here, this one does not factor. This x squared plus 4. There's no x value that will make this equal negative 4 because it's squared. It'll always be a positive. So there's nothing I can do to make a 0 here. So this will never become 0, which means this will never go off to infinity. This will never have an asymptote. This guy here, let's see. All right, so I just factored this. So this is 2 leading coefficient. You got x plus 1, x plus 3 halves. So the zeros are at negative 1 and negative 3 halves, which means this guy has vertical asymptotes at negative 1 and negative 3 halves. All right, I know number 3 isn't part of the homework, but honestly, this is a really good one to help learn about reciprocals, so I couldn't help myself. Sketch the graph of each function. Use your graph to help sketch the graph of the reciprocal. So f of x equals 5 minus x, or we could say negative x minus 5. That's just a line. When x is 0, y is 5. Right there. When x is 5, y is 0. So this line just goes like this. I missed. Okay, we'll just try that again. Yeah, that's a little bit better. Okay, now if we want to do the reciprocal of that, which would be, let's call that g of x equals 1 over 5 minus x. Really, we don't even have to look at the equation. We could just look right here. F of x is equal to 0, and so g of x will be 1 over 0. Well, that doesn't exist. So this is where we're going to have an asymptote. All right, over here, all of this, f of x is negative, so g of x will be 1 over a negative, which will also be negative. When f of x is equal to 1, which is right here, when x is 6, well, g of x will also be, so 6 comma 1, right? If f of x, well, sorry, that's when it's negative 1, duh. Okay, so at f of x, when x is 6, f of x is negative 1. Well, when g of x is 6, 1 over negative 1 is still negative 1, so it'll still be there. Now in this little region, when f of x is smaller than negative 1, g of x will be larger. And as f of x gets really, really, really close to 0, well, 1, like let's say 0.000001, well, 1 over 0.000001 is like a million. I don't know if I had the right number of zeros there, but you get the point. And so this, and this is negative 1 point, or 0.00001, so this is like negative a million, so it goes like that. And as your f of x gets larger and larger and larger, so like when f of x is 2, g of x will be 1/2. So when f of x is negative 2, I should say, g of x will be negative 1/2. When f of x is 3, negative 1/3, negative 1/4, so it gets closer and closer to 0. And so you notice f of x and g of x will always cross at 1 or negative 1. So same thing over here at 4, comma 1. Well, 1 over 1 is also 1, so they're both going to be that. As f of x gets closer and closer and closer to 0, g of x is going to get closer and closer and closer to infinity. And it's going to be positive because f of x is positive. And as f of x gets closer and closer and closer to infinity, g of x will get closer and closer and closer to 0. And they always cross right at 1. Right? So when f of x is 1, g of x is 1 over 1, which is 1. When f of x is 1/2, g of x is 2. When f of x is 1/5, g of x is 5. And so on and so forth. So this is what g of x will look like. There you go. And when you look at g of x, just the equation in itself, you can say 5 minus x. So there's an asymptote at x equals 5. Well, sure enough, there's my asymptote at x equals 5. There's the degree on top is less than the degree on the bottom. So you know it approaches 0. When x is positive infinity, you're going to get 5 minus a positive number. That's going to be negative. So you're going to have a positive over a negative. So sure enough, it will be negative. So everything fits. We could have graphed this without even knowing f of x. But the cool thing is, just knowing that they're reciprocals, you only need one of the graphs, and you could graph the other without even knowing the equation. All right, you've probably noticed that for part B, you've probably noticed that I like to factor things before I do anything. Leading coefficient being positive. This has zeros at 0 and 6. So let's start putting stuff in here. So 0 and 6. And it goes, the end behavior is going to be really, really, really big on the right. And it's 2 zeros. They're both order 1. This is just a parabola that looks like that. Now g of x, let's say, is just 1 over x squared minus 6x. Okay, well, without even looking at the equation, we could easily use the equation. We could say, oh, there's going to be an asymptote at 6 and 0. But without even looking at the equation, let's draw g of x. So when there's a 0 for f of x, we must have an asymptote for g of x. And if there were an asymptote for f of x, then that would be a 0 for g of x. All right, so there we go. So that's the first thing you do is you draw all your asymptotes where there are zeros. You draw zeros where there are asymptotes. Second thing, you see where it crosses, where it equals 1. So let's see, at 7, does it equal 1? No, at 7, it'll equal 7. All right, so at 7, it's already up to 7. So g of x is going to be down to 1/7 by that time. Okay, and as this gets bigger and bigger and bigger, g of x is going to get smaller and smaller and smaller. So it actually, at 6 point something small, that's where it's going to equal 1. So it's going to cross like that. Notice that as right here, as it gets really, really, really close to 0, that's when this orange one's going to get really, really close to infinity. This is positive, and so will this. Whenever one is positive, the other one has to be positive, because 1 over a positive is a positive. Right? So the same thing happens on the other side. It crosses right when the y value is 1, and whenever the blue guy is really, really, really small, then the orange girl is really, really, really large. And when the blue guy gets really, really, really large, the orange gets really, really small. And right at 1 is where they cross. But remember, they're always positive at the same time. Positive at the same time. So what happens on the other side? Well, it's just inside here where it equals 1. So that's where they're going to cross. And right here, let's say. It's actually tighter than that, but I'm drawing with my finger here. And because blue is like super small, under 1 over there, it's going to be over 1 here. And goes like that. Okay, so other things to notice is whenever blue is going down, orange will be going up. Blue is going down and then up, orange is going up and then down. Blue is going up, orange is going down. Whenever blue is at 0, orange has an asymptote. Whenever blue has an asymptote, which it doesn't, orange will have a 0. So notice blue has no asymptotes. That means orange has no zeros. Whenever blue is positive, orange is positive. Whenever blue is negative, orange is negative, and vice versa. Right, number 5, state the equation of the reciprocals of each function and determine the equations of the vertical asymptotes of the reciprocal. Verify your results using graphing technology. So first, state the equation of the reciprocal. Okay, the equation of the reciprocal, that should be easy. A. Let's call it g of x. Actually, let's call it, since it's the reciprocal, let's call it 1 over f of x. That's the exact thing that we should call it, right? So it's just 1 over is going to be 1 over 2x. B, 1 over f of x, which is the reciprocal of f of x, is 1 over x plus 5. C, 1 over f of x equals 1 over x minus 4. D, 1 over f of x equals 1 over, I'm going to factor this one, 2x plus 5 halves. I have a feeling it'll help me in the future if they ask me to do other things. E, 1 over f of x equals 1 over, again I'm going to factor it, negative 3x minus 2. F, 1 over f of x equals 1 over x minus 3, x minus 3. It's nicer to look at expanded like that. G, 1 over f of x equals 1 over, what is this, x minus 5, x plus 2. And H, 1 over f of x equals 1 over 3x plus 2 x minus 2. I better double check that. So it's 3x squared plus 2x minus 6x. Yep, minus 4. Okay, perfect. All right, so that was stating the equation of the reciprocal of each function. I didn't have to factor them. I just thought it would be easier later. Determine the equation of the vertical asymptotes of the reciprocals. Okay, that's just where the bottom equals 0. So the zeros here will just be the vertical asymptotes. So the equation of the vertical asymptotes. Let's do that in blue. This one's going to be x equals 0. This one's going to be x equals negative 5. X equals 4. X equals negative 5 halves. I was right that factoring did help. X equals 2. X equals, is that negative 3 twice? So just 3. And that is order 2, right? Order 2. X equals 5 or negative 2. And x equals negative 2/3 and 2. All right, what else does it want us to do? Verify your results using graphing technology. Okay, I'm doing that. You can't see it. There, I just did it. And yep, I was right. Okay. You can actually do the graphing technology if you want, but I'm moving on. Number 6. All right, sketch the graph of the reciprocal of each function. Oh, this is like the bread and butter of this section. This is awesome. All right, so we have a 0 right here. So that's where I'm going to have an asymptote because 1 over 0 is undefined. And because we are approaching 0 on both sides, one's in the positive, one's in the negative, that means I'm approaching infinity on both sides. And so this is getting closer and closer to 0 positive. So on this side, we're getting closer and closer to infinity, positive side. Here we're getting closer and closer to 0 on the negative side. So we're getting closer and closer to infinity on the negative side. Where does it actually cross? Right when it is at -1 and +1. That's where they're going to cross. So I got to make sure I get that in deep, close there. Oops, I missed. It's hard with my finger. Let's try that again. All right, so we got to go like that and try to cross right there. Boom. And now as the blue gets farther and farther negative, like really, really, really large negatives, like -6, that's going to be -1/6, -7, -1/7. So this is going to get closer and closer to 0. And on the positive side, when this is going up to 2, 3, 4, 5, 6, this is going to 1/2, 1/3, 1/4, 1/5, 1/6. And so it gets closer and closer to 0. There you go. There are no asymptotes on this blue line, so there will be no zeros on this orange line. All right, so here's a 0 right away for part, I guess I'll do part C before part B. Let's make this an asymptote. Right, because on this side it's approaching 0, so as it gets closer and closer and closer to 0, this side is getting closer and closer and closer to infinity. Where does it cross? Right at 1. So this blue line is at 1 right here. So this guy's got to stay nice and tight and cross at 1. Now this guy goes all the way up to 6, so this guy has to go all the way down to 1/6. So it goes to 2, 3, 4, 5, 6. This should go to 1/2, 1/3, 1/4, 1/5, 1/6. This is going to be nice and tight to the x-axis. Let's go like that. And the same thing on the other side. It's going to cross right almost at the thing, and it's going to go up like that. And then nothing happens because the blue doesn't exist to the left of -6. That's not in its range. So 1 over not exist is still not exist. 1 over doesn't exist is still doesn't exist. And so that's it. It's just like that guy. All right, let's consider this next one. So we've got, again, no asymptotes to deal with, but that's okay. We have a 0 here. So I have an asymptote there. It'd be nice to have the blue with an asymptote so I can show you that that'll give me a 0. The only way to get a 0 in the reciprocal is if we have an asymptote in the original. All right, what else we got here? So we've got at -1, it crosses -1 right here and here. So I know that it's gonna, the orange will also cross -1 there because 1 over -1 is just -1. And it crosses 1 right here and right here, so that's where I'm going to be at 1. And as the blue is under 1, it's like 1/2, the orange will be 2 right there. And when it gets closer and closer to 0, this gets closer and closer to infinity. And as the blue gets higher and higher, this guy gets lower and lower. Remember, the positive stays positive, negative stays negative. So the blue is really, really close to 0 here. It goes down to -2, so this will go up to -1/2. and it goes back down to negative infinity, and it starts at 0, so it starts like that, and it goes that way. That's nice. Okay, here my 0 is my asymptote for the reciprocal, and it's just shooting up to infinity on both sides, so this will just shoot down to 0. So the y-intercept is 2 for my blue one, so the y-intercept will be 1/2 for my orange one. It's going to go from infinity down like that. And this guy's going to do the same thing, nice and symmetrical, like that. And it should cross right at 1 for both sides. And notice the blue never did go to the bottom. So the orange never did go to the bottom because the blue was never negative, so you'll never have negative orange because 1 over a positive is a positive. 1 over 0 doesn't exist, so that's why you've got no value right here. And the fact that it approaches 0 on both sides means that it approaches infinity on both sides, and that's what makes it an asymptote. All right, sketch each pair of graphs on the same axes. State the domain and range of each reciprocal function. So we'll just do A at first. I took the time to go y equals 2x minus 5. I changed it to y equals 2 times x minus 5/2. It just makes it, I don't know why I like to see that all the time, but I know this is at 5/2. I know there's a 0 there, so I know that's reciprocal. Let's do the reciprocal in orange, and let's do the original in blue. This one is in blue. All right, so the reciprocal is going to have an asymptote right there. Okay, the blue one, that's just a line with a slope of 2. And so when x is 0, we're going to get negative 5. So the orange one, when x is 0, you're going to get negative 1 over 5. Negative 1 over 5, the reciprocal. Where is it actually equal to 1 here? So we see at 2, right about here, right at 2, that's when you're going to get negative 1. And so at 2, negative 1 is where they're going to cross. Okay, the reciprocal will also be 2, negative 1, because 1 over negative 1 is negative 1. Remember, they always cross their reciprocals at 1 and negative 1. So at 3, you're going to get positive 1 for both of them. And it's going to do that. There you go. What does it ask us to do exactly? So sketch each pair of graphs. There we go. State the domain and range of each function. I'm just going to say it in words. So the domain of this reciprocal function is all r, comma, x cannot be 5/2, and the range is going to be all y belong to r, comma, y cannot equal 0. So part B, again, we just have a line here with a 0 at negative 4/3, which means I'm going to have an asymptote at negative 4/3 for my reciprocal, which is right here. And this has a slope of 3. My original, it's just a straight line with a slope of 3. It crosses, when x is 0, we've got 4. So it crosses at 4. Well, if that crosses at 4, where does the reciprocal cross? Well, 1 over 4. And when this one is 1 over 4, well, the reciprocal will be at 4. And when this guy is at 1, the reciprocal will also be at 1. Because 1 over 1 is 1. And as the blue guy gets larger and larger and larger and larger, the reciprocal gets smaller and smaller and smaller and smaller. When it's 4, 5, 6, 7, 8, 9, this is 1/4, 1/5, 1/6, 1/7, 1/8, 1/9. All right, in the negative side here, when the blue does hit 1, somewhere in here, the orange will also hit 1. As the blue is smaller than 1, the orange is larger. As the blue is larger, the orange is smaller. So as the blue hits, 1/2, 1/3, 1/4, this hits 2, 3, 4, 5. When it's like 1/100th, this is at 100. When this is at like 1/1,000th, this is way down to 1,000,000. As this gets to 3, 4, 5, 6, 7, this gets to 1/3, 1/4, 1/5, 1/6, 1/7. Okay? And when this equals 1, they both equal 1. So make sure they always cross when y is 1. Domain and range. We can say the domain of this orange one is x belongs to R, so everything in R except at -4/3, so x cannot be 4/3, and the range is x belongs to R, or sorry, y belongs to R except y cannot equal 0. All right, I'll just do one of these and I'll leave the rest for you guys. There's no point in me doing all of these. Maybe I'll do A and I'll do E because I see something a bit strange about E. For B, yeah, you're gonna have to you'll probably have to expand this and then simplify to be able to graph it better. For C, no problem, you'll just have to factor. D will be super easy. Realize that this is a 0 at -3, but it's of order 2, so it'll just bounce off. So it'll just kind of go like this, bounce back up and go up. This guy I'm going to do for you, that's not even going to ever hit 0. It's just going to go like that. It's going to cross here at 2. This one you'll have to expand and then simplify. So, all right, let me do part A. So draw the graph of f of x. So x squared minus 4, that's just y equals x squared, but down 4. Like that, and x is 2 and -2, because when you factor this, it's just x minus 2, x plus 2. All right, so there's my graph of f of x. Now y equals 1 over f of x on the same graph. Okay, we'll make that one green. Well, when I have a 0, I can have an asymptote. 0 gives me an asymptote. This goes all the way down to -4, so I'm going to go up to -1/4. -1 over 4. This is -4. And since this is going down to, since this part here is getting really close to 0, I'm going to be at going to -infinity. When it hits 1, I'm going to hit 1, or sorry, -1, -1. And so it just has this shape. Like that. I think I missed that. Let me try that again. Not that this is much better, but so this crosses at 1 whenever y is 1. Sorry, -1 again. So it's actually like √3, comma, -1. And -√3, comma, -1. That's where they'll cross, like -1.7 something, I guess. And then these guys go like this, and they cross also at something, comma, 1. Right here, they cross at something, comma, 1. That something will be -√5 and √5. So there you have it. Part E just goes like this. It's another parabola. So basically the same parabola, but up 6. This crosses at 2. So let's see. Let's make its reciprocal in black. So there are no asymptotes on for the reciprocal because there's no place where this hits 0. This is on the y-intercept. The y-intercept is 2. So the y-intercept for its reciprocal will be 1 over 2. All right, so that'll be like 1/2 right about here. And since this never gets down to 1, it will never cross its reciprocal because it could only cross at 1 or -1. this is going from 2 to 3, 4, 5, 6. This is going to go from 1/2 to 1/3, 1/4, 1/5, 1/6. So it's just going to go down. So this is going to go like this and back down. Right. And that's it. That's its reciprocal. Notice the green is always positive, so is the black, because 1 over any positive is just a positive. Green gets bigger this way and that way, black gets smaller this way and that way. When green is 3, black is 1/3. When green is 5, black is 1/5. Alright, let's see what number 9 is. Alright, for each function determine the domain and range, intercepts, positive, negative intervals, and increasing, decreasing intervals. State the equation of the reciprocal function, then sketch the graphs of the original and reciprocal functions on the same axes. Alright, before moving on, I put these all in factored form. I think it'll make life easier for me here. Alright, I also know that it asked me to sketch the graph of the original reciprocal on the same axis. It told me to do that last, but I think that'll be the easiest thing right away. I already know everything I need to know to graph it and its reciprocal, so I might as well go right to it. So we can see that this has a 0 at x is -4. The y-intercept, so when x is 0, is just going to be 8. And this is linear. We already have 2 points, so we know it goes just like this. The reciprocal function will have an asymptote where the 0 is, so at -4. At -3.5, it crosses 1, so they'll both cross at that spot, and it will just go like so. Same thing at -4.5, -4.5, comma -1, and that's where it'll cross again. And there you go. Since my blue line doesn't have any asymptotes, my orange line won't have any zeros. Alright, now I think this will be easier. The domain and range. So the domain is all x such that x belongs to R. We're only talking about the blue one here. So there are, it's goes from -infinity to +infinity. There are no holes or asymptotes. And the range goes from the top all the way to the bottom, or bottom all the way to top. So the range is all y values such that y belongs to R. Now I should take care of the problem that there's no y here, so I should say let y equal f of x, and then I could do that and it's still fair. So I could say y instead of f of x. Alright, intercepts next. Well, it's got an x-intercept at -4, 0, and it's got a y-intercept at 0, 8. Positive, negative intervals, so that's just where it's above or below the x-axis. So it's below the x-axis from whenever x is less than -4, and it's above the x-axis whenever x is greater than -4. So for here, this is your negative interval, and this is your positive interval. Increasing, decreasing. The blue, if you go from left to right, it's always going up, so it's always increasing. So always increasing, or I can say increasing at x belongs to R. And the equation of the reciprocal function, the equation of the reciprocal, that's probably the easiest of all of them. The equation is 1 over f of x equals 1 over 2x plus 8. You just have to do 1 over the function. There you go. We're done. I think you guys could do that for B, C, and D without any problems. All right, why do the graphs of reciprocals of linear functions always have vertical asymptotes, but the graphs of reciprocals of quadratic functions sometimes do not? Provide sketches of 3 different reciprocal functions to illustrate your answer. All right, let's start off with I'm just going to do it messy here. Let's start off with linear. Linear, I guess we're not talking about degree 0, where it's just a horizontal line. Linear, we're talking about degree 1, where there's always a slope that's a non-zero slope. So we're talking y equals ax plus b, and a is not equal to 0. And so in that case, there will always be an x-intercept. Therefore, the reciprocal, that means there will always be a value of y that equals 0. And so the reciprocal will always have a value of y, 1 over ax plus b. A is not 0, where the bottom is equal to 0. And if the bottom equals 0, that means we have ourselves a discontinuity, but also a line is always approaching 0 from both sides, one on the negative and one on the positive, and so its reciprocal will be approaching infinity on one from the negative and one on the positive side. Okay, so that's why lines will always have the reciprocal, since it always has a 0 and it always approaches 0 on both sides, the reciprocal will always have a discontinuity, and it'll always approach a discontinuity by going to infinity and negative infinity, which means it is an asymptote. All right, graph number 2. Here's a quadratic that does not cross 0, and so its reciprocal will not ever get to 1 over 0, because, so let's see, f of x equals, all right, the third graph I can show is a parabola that actually does cross. Well, when this equals 0, its reciprocal will have an asymptote. Same as for the line, because this approaches 0, and this from both sides, the reciprocal will approach infinity, because 1 over a very small number is a very large number from both sides. There's another situation I should talk about. Let's see what happens here. Let's say we have a parabola that just kisses, like just touches the x-axis. Then what happens right here? Well, it still does get really, really close to 0 on both sides, but it stays positive. And so its reciprocal will get really, really close to infinity, but it'll stay on the same side. So that's interesting, because we already saw that when we have a polynomial with a double, like this would be x minus 4 squared, right? If it's order 2, then it just comes, it balances off like that. Well, it explains why 1 over x minus 4 squared is going to be staying. If it goes up like this, it'll stay on the same side there, because its reciprocal bounces back up to the same side. So when it comes down, it's going to be coming from the same side as well.